February 27, 1943, the Hardangervidda Plateau, Norway. Lieutenant Joachim Runneberg crouched in knee-deep snow, watching his breath freeze in the -20-degree air as he counted the sentries pacing the perimeter fence below. 12 men visible, another 20 likely inside the facility's heated guardhouse. His hand moved to the weapon strapped across his chest, a Sten gun that shouldn't exist. The silencer attached to its barrel violated every British Army regulation on the books. The Ordnance Board had explicitly forbidden field modifications to the Sten's design. Too dangerous, they'd said, unreliable, likely to explode in the user's hands. Runneberg's fingers traced the homemade suppressor welded to the barrel by Station 17th's weapons section back in England. The engineers who'd built it had sworn him to secrecy. If this mission failed, if questions were asked, they'd deny the device ever existed. He checked his watch. 45 minutes until the sabotage teams moved on the heavy water plant. 45 minutes to eliminate every guard between them and the target without firing a single unsuppressed shot. A single alarm would bring German reinforcements from Rjukan. 3 miles down the mountain, the mission would fail. Norway's resistance network would be compromised, and the Nazi atomic weapons program would continue unimpeded. Runneberg glanced at the 5 commandos positioned along the ridgeline. Each carried the same illegal weapon. Each had been told the same thing during final briefing. The silencers were experimental, untested in combat conditions, and might fail catastrophically at any moment. What happened in the next hour would either prove the Ordnance Board's fears justified, or demonstrate that sometimes the most effective weapons are the ones authorities refuse to authorize. For 18 months, Allied intelligence had watched with mounting alarm as Nazi Germany accelerated its nuclear research program. At the center of that effort stood a single facility, the Vemork hydroelectric plant in southern Norway, the only industrial-scale producer of heavy water in occupied Europe. Heavy water, deuterium oxide, was the critical moderator German physicists needed for their experimental nuclear reactors. Without it, their atomic weapons research would stall indefinitely. With steady supply from Vemork's electrolysis cells, they might achieve a functioning reactor within 2 years. British intelligence estimated German heavy water production at 120 kilograms monthly by late 1942. Werner Heisenberg's team in Berlin needed at least 1,500 kilograms for their reactor design. The mathematics were terrifying. Left unchecked, Vemork would provide sufficient material by mid-1944. The first attempt to stop production had come in November 1942. Operation Freshman sent 2 Halifax bombers towing gliders packed with Royal Engineers toward Vemork. Both gliders crashed in the Norwegian mountains. 34 British soldiers died in the wrecks or were captured and executed by the Gestapo under Hitler's Commando order. The heavy water continued flowing. By February 1943, London had no conventional military options. Bombing raids were impossible. Vemork sat at the bottom of a steep-sided valley, surrounded by civilian housing, virtually immune to level bombing. The facility itself was built into solid rock, protected by layers of reinforced concrete. Even if bombers could hit the valley, they'd massacre Norwegian civilians while barely scratching the plant. Special Operations Executive proposed an alternative. A small team of Norwegian commandos trained in Scotland, dropped by parachute to link up with local resistance members. 6 men to infiltrate the most heavily defended industrial target in occupied Norway. But the security made it nearly suicidal. German intelligence, stung by the Freshman disaster, had flooded the region with troops. SS and Wehrmacht units patrolled the approaches. The plant itself maintained 32 guards on duty every night, 12 outside in rotating patrols, 20 inside monitoring entrances and critical infrastructure. And here was the tactical impossibility. The commandos would need to cross 600 yards of open ground, eliminate every external guard, breach the perimeter, and place explosive charges on the electrolysis cells, all without triggering an alarm. A single guard reaching an alarm panel would bring hundreds of German soldiers. A single shot from an unsuppressed weapon would echo across the valley, alerting garrisons in Rjukan below. Standard Sten guns, Britain's mass-produced submachine gun, fired at 500 rounds per minute with a sound signature audible for over a mile in still air. Silencers existed for specialized weapons, but the Sten's open-bolt design made suppression theoretically impossible, according to British Army ordnance experts. The bolt slamming forward created mechanical noise no silencer could eliminate. The weapon's crude manufacturing tolerances made it unsafe to modify. Station 17th, SOE's weapons development facility in Hertfordshire, had ignored those assessments. Their engineers believed a properly designed suppressor could reduce the Sten's report enough for close-quarters elimination missions. They'd built prototypes, tested them on their firing range, achieved promising results. But promising results in controlled conditions meant nothing in combat. The suppressors added weight that might affect reliability. The cold Norwegian climate could cause malfunctions. The devices had never been used in an actual assassination scenario, and officially, they didn't exist. The Ordnance Board had refused certification. Army regulations forbade field modifications to weapons systems. SOE issued them anyway to Runeberg's team with a verbal caveat. If captured, deny the suppressors came from British sources, claim they were Norwegian resistance fabrications, protect the engineers who'd built them. What the 6 commandos now preparing to assault Vemork understood was simple. They were betting the entire mission, and potentially the outcome of the Nazi atomic program, on an illegal weapon that the British Army's own experts believed might kill them before it killed any Germans. The German assessment of Vemork's security was built on hard-earned confidence. After the freshman disaster, Wehrmacht intelligence had concluded that British commandos lacked the capability for successful penetration of heavily defended targets in mountainous terrain. The analysis made sense. Freshmen had deployed 34 highly trained Royal Engineers. All had died or been captured within hours. If Britain's best assault troops couldn't reach Vemork, what chance did a handful of Norwegian expatriates have? German security doctrine reflected this confidence. The 32 guards assigned to night shift weren't elite troops. Most were older Wehrmacht soldiers or Norwegian collaborators from the Hindered, Quisling's paramilitary force. They worked rotating 4-hour shifts, with guards returning to heated facilities every hour to prevent frostbite. The cold itself was considered a defensive layer. No attacking force could remain motionless in -20-degree weather for extended periods. The garrison commander, Lieutenant Muggenthaler, had argued for reduced manning after Christmas. The plant's isolation, the mountain terrain, the catastrophic failure of freshmen, all suggested that maintaining 32 guards nightly was excessive. Berlin had rejected the request, but Muggenthaler's confidence in the defensive position never wavered. What the Germans couldn't know was that the freshman operation had taught SOE exactly what wouldn't work. Gliders were too vulnerable. Large assault forces were too visible. Timing missions to aircraft schedules created inflexibility. The solution was counterintuitive. Fewer men, not more. Local knowledge, not external force. Patience over speed. But even with revised tactics, the fundamental problem remained. You couldn't infiltrate 32 alert guards with knives and garrots. Hand-to-hand combat was too slow, too uncertain. A single guard escaping into the plant would doom the mission. Standard suppressed weapons, the well-rod pistol, the delesal carbine, had insufficient range and rate of fire for multiple targets in open terrain. The Sten's 9mm round and 500 round per minute cyclic rate made it ideal for close-quarters combat, but its mechanical noise signature defeated the purpose of suppression. Military doctrine held that suppressed submachine guns were impossible. The physics didn't work. Station 17's prototypes contradicted that doctrine, but laboratory testing wasn't combat validation. Runneberg's team had practiced with the modified Stens in Scotland, firing into snowbanks to test sound signature. The results were promising. The suppressed report was comparable to a pneumatic hammer from 50 yards, possibly quiet enough for stealth eliminations if targets were isolated, but promising wasn't certain. And in the Hardanger Vita in February, with 32 armed guards and no alternative plan, promising would have to be enough. The commandos knew one other thing. If the silencers failed, if mechanical malfunctions or design flaws rendered the weapons inoperable, they carried no backup suppressed firearms. They'd be forced to abort or attempt knife eliminations against numerically superior forces. By the evening of February 27th, as 6 Norwegian commandos prepared to descend from their observation positions, the entire mission rested on an experimental weapon system that officially didn't exist and that British ordnance experts had declared unsafe for combat use. The infiltration began at 2300 hours. 6 men moving in single file down the steep slope, weapons slung using the terrain's natural dead zones to mask their approach. Runneberg led, followed by Knut Haukelid, Frederick Kaiser, Kasper Edlund, Hans Storhaug, and Birger Strömsheim. Each carried a suppressed Sten gun loaded with a 32-round magazine. Additional magazines were distributed in webbing pouches, 196 rounds total between them. The temperature had dropped to minus 22 degrees Celsius. Every exhale created visible vapor that could betray position. The commandos breathed through wool scarves wrapped around their lower faces, warming the air before it escaped. By 2330 hours, they'd reached the tree line, 400 yards from the perimeter fence. Runneberg signaled halt. Through binoculars, he counted guards. 4 visible on external patrol, 2 at the main gate. Movement in the guardhouse windows suggested the day shift preparing for turnover. The guard rotation would happen at midnight. 6 fresh guards would replace the current external patrol. That transition, 15 minutes of confusion, men entering and leaving the heated guardhouse, was the window. But first, the external patrol had to be eliminated. Runneberg assigned targets. Haukelid and Kaiser would take the 2 guards on the southern perimeter. Idland and Storhaug had the northern section. Runneberg and Strömsheim would handle the gate guards. Timing was critical. All eliminations had to occur within a 90-second window. Any longer and a guard might notice his partner missing. At 23:45 hours, they moved into position. The commandos used a herringbone crawl, keeping bodies flat, weapons cradled across forearms, moving during moments when guards looked away or turned their backs. It took 12 minutes to close to effective range, 50 yards, close enough to guarantee first-shot accuracy, even with the added weight of suppressors affecting barrel harmonics. Runneberg's watch showed 23:57. He raised his hand. 5 commandos froze, weapons shouldered, safeties off. The signal came at 23:59. His hand dropped. 6 suppressed Sten guns fired simultaneously. The sound was like heavy doors slamming in sequence, dull mechanical thumps rather than the sharp crack of unsuppressed gunfire. The 9mm rounds struck at roughly 100 feet per second. Each commando fired 3-round bursts, 18 rounds in 4 seconds. 4 German guards collapsed in the snow without a sound. The 2 gate guards staggered, one reaching for his whistle, before Strömsheim's second burst caught him center mass. No alarm sounded. No shouts echoed across the valley. Inside the guardhouse, men prepared for shift change, unaware that half the external patrol had just been eliminated. Runeberg hand-signaled advance. The 6 commandos moved forward at a run, crossing open ground while the corpses were still warm. They dragged bodies into shadows, propped them against walls to create silhouettes that might fool casual observation from inside. The midnight shift change began at 0:01. The guardhouse door opened. 6 replacement guards emerged, stamping feet against the cold, rifles slung casually. They expected to find their counterparts at assigned positions. Instead, they walked into a pre-positioned ambush. The commandos had spread along the guardhouse exterior wall, weapons aimed at the exit. As each German guard stepped through the door, he was met with suppressed gunfire from multiple angles. The tactic was called stacking the ambush. Overlapping fields of fire that guaranteed multiple hits regardless of target movement. The suppressed Stens cycled at their full 500 round per minute rate. The sound was still loud, metal bolts slamming, mechanical action cycling, but critically it didn't sound like gunfire to anyone inside the guardhouse. It sounded like machinery, generators, the industrial ambient noise that permeated the Vemork facility every hour of every day. 6 more German guards died in the span of 20 seconds. The commandos ceased fire. 12 external guards eliminated, 20 remain inside. But now the tactical picture had changed dramatically. The interior guards had no idea what was happening outside. They sat in their heated break room, playing cards, drinking coffee, waiting for their shift. They had no reason to suspect anything was wrong. Runeberg made the critical decision: don't breach the guardhouse. It wasn't necessary. The demolition team, Haukelid, Kaiser, Eidland, and Storhaug, only needed to reach the electrolysis cells in the plant's basement. That route bypassed the guardhouse entirely, following a railway track that entered through an external door. The 4 demolitions experts moved toward the plant entrance, while Runeberg and Strömsheim maintained overwatch position. If guards emerged, if someone inside noticed the absence of external patrols, the 2 rear guards would engage with suppressed fire to buy the others time. At 15 hours, the demolition team breached the railway entrance using bolt cutters on a chain-link gate. They moved through darkened corridors toward the heavy water concentration cells, 18 stainless steel cylinders containing the deuterium oxide that represented 18 months of Nazi production. Inside, 1 Norwegian guard, a plant employee forced into collaboration, stood watch. Kaiser approached from behind, pressed a knife to the man's throat, and whispered in Norwegian, "Stay silent. We're here for the Germans, not you. Lie face down, you'll live." The guard complied. The commandos placed 18 charges of plastic explosive, 4 kilograms total, on connection pipes linking the concentration cells. 30-second fuses. Detonation scheduled for 5 hours. They withdrew the way they'd entered, leaving the Norwegian guard alive and bound but unharmed. Outside, Runeberg did a final count. 12 bodies visible in the snow. No activity from the guardhouse. The interior guards remained oblivious, warm and comfortable, expecting their counterparts to be freezing at their posts as usual. At 43 hours, 6 Norwegian commandos reached the tree line and began their ascent back toward the Hardanger Vidda. Behind them, the Vemork plant sat silent in the darkness. The charges detonated at 0455. 18 heavy water cells ruptured simultaneously. 450 kilograms of deuterium oxide, half a year's production, flooded into drainage systems and dissipated into the Mona River. By the time German guards inside the facility responded to the explosion, the saboteurs had vanished into the mountains. 32 guards had been assigned to protect Vemork that night. 12 died, 20 survived, completely unaware that enemy commandos had been operating within 50 yards of their position. The technical success of the operation stunned SOE analysts when Runeberg's after-action report reached London in March 1943. The modified Sten guns had performed flawlessly. No mechanical failures, no jams despite the extreme cold, no catastrophic malfunctions predicted by Ordnance Board assessments. Station 6's engineers conducted detailed debriefings with the team after their exfiltration to Sweden. The suppressors, manufactured from drawn steel tubing within internal baffle systems, had reduced muzzle report by approximately 32 decibels. More critically, they had eliminated the distinctive crack of supersonic bullets, since the 9mm rounds at close range remained subsonic when fired through the extended barrel length. But the real revelation wasn't acoustic, it was psychological. The suppressed Sten's mechanical noise, bolt slamming, action cycling, blended perfectly with industrial environments. German guards inside Vemork had heard the firefight happening outside their windows and interpreted it as machinery noise, generator fluctuations, normal facility operations. The human brain filters familiar sounds as non-threatening. The modified Stens exploited that perceptual vulnerability. Intelligence analysis revealed another advantage. Suppressed weapons created paralysis in surviving enemies. Unsuppressed gunfire triggers immediate instinctive responses. Take cover, return fire, sound alarm. Suppressed fire creates confusion. Guards couldn't identify shot direction. They couldn't determine how many attackers were present. Some didn't recognize they were under attack until rounds physically struck them. The Norwegian guard who'd been spared inside the facility later testified that he'd heard thumping sounds but assumed it was equipment being moved. When the commandos appeared, weapons raised, his first thought was that they were fellow workers. The psychological disconnect between weapon in hand and no gunshot sound delayed threat recognition by critical seconds. Station 17 immediately accelerated production of the suppressor design. Within 6 weeks, modified Stens were being issued to SOE teams throughout occupied Europe. The weapons proved particularly effective in urban environments. Paris, Brussels, Copenhagen, where ambient noise masked the mechanical sounds completely. The Ordnance Board's concerns about reliability were addressed through metallurgy improvements. The original Vemork suppressors used commercial steel tubing. Production versions incorporated higher-grade alloys resistant to thermal stress and fouling. Service life increased from roughly 500 rounds to 2,000 rounds before performance degradation. But bureaucratic resistance persisted. The Army refused to officially adopt the suppressors, maintaining that modifications to standard weapons violated safety protocols. The devices remained classified as experimental equipment throughout the war. Official documentation referred to them only as sound moderators, rather than silencers or suppressors, a semantic distinction that allowed plausible deniability. SOE circumvented these restrictions by issuing the weapons through irregular channels. Commandos received them during final mission briefings, returned them after operations, and were instructed never to reference them in written reports. The fiction was maintained that all eliminations had been conducted with knives or garrots. German intelligence eventually recovered spent suppressors from failed SOE operations. By late 1943, Wehrmacht security bulletins warned guards that British commandos possessed sound-dampened automatic weapons. Counter tactics were recommended: increased interior patrols, acoustic sensors, guard rotations designed to prevent isolation of individuals. But by then, the technology had evolved beyond what German intelligence understood. Station 17th had moved on to integral suppressor designs, weapons manufactured with built-in sound reduction rather than attachable devices. These weapons were quieter, more reliable, and impossible to distinguish from standard firearms through visual inspection. The Vemork raid had proved the concept. Close-quarters elimination using suppressed submachine guns was not only possible but tactically superior to knife attacks or conventional assault. The technique would be refined and expanded throughout the remainder of the war, fundamentally changing how special operations forces approached infiltration missions. What had begun as an illegal field modification, explicitly prohibited by military regulations, became standard doctrine for covert operations, a doctrine still employed by special forces worldwide 8 decades later. The immediate impact on Nazi Germany's atomic weapons program was catastrophic. The destruction of Vemork's heavy water stocks set German nuclear research back by at least 18 months. Werner Heisenberg's reactor experiments in Berlin were postponed indefinitely. Plans for scaled-up production were abandoned. Germany attempted to restart operations at Vemork within months. By November 1943, the plant had produced another 600 kilograms of heavy water. The Allies responded with massive bombing raids that rendered the facility permanently inoperable. The Germans then attempted to evacuate remaining stocks to laboratories in Germany. Norwegian resistance, tipped off by intelligence networks, sank the ferry Hydro carrying the heavy water across Lake Tinnsjø. 14 tons of material sank to the bottom in February 1944. By the time Germany surrendered in May 1945, their atomic program had achieved nothing approaching weapons development. Allied intelligence teams entering Germany discovered reactor designs that were years behind the Manhattan Project. The absence of heavy water had been a critical limiting factor. Joachim Runeberg survived the war and lived until 2018, dying at age 99. He received Norway's highest military decoration, Britain's Distinguished Service Order, and was appointed honorary colonel in the British Army. He rarely discussed the Vemork operation publicly, maintaining operational security protocols decades after the mission had been declassified. The other 5 commandos all survived the immediate aftermath. Knut Haukelid remained in Norway, organizing resistance operations until liberation. Frederick Kaiser escaped to Sweden, then Britain, and continued operating with SOE. All received military decorations from both Norwegian and British governments. The suppressed Sten gun design was never officially acknowledged by British military authorities. Post-war weapons inventories made no reference to the station's 17th modifications. The devices were quietly destroyed or reclassified into deeper levels of secrecy. Not until the 1970s, when former SOE personnel began publishing memoirs, did public awareness of the weapons emerge. Modern special forces regard Operation Gunnerside as a masterclass in economy of force. 6 men achieved what 34 had failed to accomplish. The differential factor was tactics, local knowledge, and appropriate weapons technology. Military academies worldwide study the operation as an example of how small, well-equipped teams can achieve strategic impact against numerically superior forces. The heavy water itself became a historical footnote. Post-war analysis suggested that German reactor designs were fundamentally flawed regardless of material availability. Even with unlimited heavy water supplies, Nazi physicists might never have achieved a functioning atomic bomb. They'd pursued incorrect theoretical approaches, lacked industrial capacity for uranium enrichment, and suffered from Hitler's dismissal of Jewish physics that hampered collaboration with remaining German scientists. But the counterfactual remains. What if Vemork had continued production unimpeded? What if Germany had possessed functional reactors by 1944? What if plutonium production had become possible? The commandos who descended into that valley in February 1943 couldn't know those answers. They knew only that eliminating 32 guards without triggering an alarm required weapons that officially weren't supposed to exist, and that sometimes the most critical military innovations happen when regulations are ignored and impossible becomes merely difficult. Innovation in warfare rarely follows approved channels. The weapons that change tactical paradigms emerge not from committee meetings and procurement boards, but from engineers willing to ignore doctrine and operators willing to test untried systems in lethal environments. The suppressed Sten violated regulations because regulations were written by people who'd never needed to eliminate 12 guards silently in sub-zero darkness. Ordnance Board experts rejected the design because they optimized for safety margins and manufacturing consistency, not for the specific moment when mission success depends on sounds that don't echo across valleys. The lesson isn't that military regulations should be casually dismissed. It's that rigid adherence to doctrine creates brittleness. The organizations that adapt fastest aren't those with the most comprehensive rulebooks. They're those that empower small teams to identify problems and implement solutions without waiting for authorization from headquarters thousands of miles away. 6 Norwegian commandos and a handful of British engineers accomplished what conventional military planning deemed impossible. They did it by recognizing that sometimes the most dangerous weapon isn't the one that fires the most rounds or penetrates the thickest armor. It's the one that allows skilled operators to get close enough that superior numbers and defensive positions become irrelevant. 32 guards vanished because someone decided that we can't do that was less compelling than what if we tried. Sometimes the weapons authorities refuse to authorize are exactly the ones that missions require.